Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Trigonometric Identities, Formulas, and Equations. Question 6, the sine squared theta divided by 1 plus the cosine of theta is equivalent to 1. To order this complete Cram session, inbox me at memedicine@gmail.com for pricing. Also inquire about pricing for other subject areas. Good luck studying. Let's delve into the question. Review question 6. Solve algebraically for all values of theta in the interval 0 degrees is less than or equivalent to theta is less than 360 degrees that satisfy the equation the sine squared theta divided by 1 plus the cosine of theta is equivalent to 1. All right, I'll give you a moment to press pause and think out and express your solution, okay? All right, hopefully by now you've arrived at an answer, and if not, that's totally fine. Let's delve into this together. So, after careful inspection, you'll notice that the equation given here in the question stem involves two different trigonometric functions. The base function here is sine anyway, the sine squared of theta, and the cosine theta. All right, so if you put on your thinking hat, you'll realize that you can get somewhere using the Pythagorean identity, which states that the cosine squared of theta plus the sine squared of theta is equivalent to 1. Okay? Now we can rearrange this identity to isolate the sine squared theta by itself because we eventually want to plug it into this equation. So let's do that. When we subtract the cosine squared of theta from the left-hand side, we end up with the sine squared theta is equivalent to 1 minus the cosine squared of theta. Okay? So hopefully, you're not exhausted yet because we still have a little ways to go, but this is the track that you're going to use if you're solving by hand. And this is an important variation used to change the sine squared of theta into a function of the cosine theta, because when we substitute back into the original equation stated in the problem stem, we're going to have everything in terms of the cosine theta. Okay? All right, so now let's do just that. Let's substitute for the sine squared of theta. Again, the sine squared of theta is over 1 plus the cosine of theta is equivalent to 1. Now, when we go ahead and substitute, we get 1 minus the cosine squared theta in the denominator, as shown here, divided by 1 plus the cosine of theta is equivalent to 1. Okay, so the next step that we're going to take is we are going to cross multiply, all right? And before we cross multiply, it's important to note that every rational number has an invisible 1 in the denominator if you look at the number itself as a numerator, okay? So let me show you what I'm talking about. So basically, you have an invisible fraction bar and a 1. So that's how we're going to cross multiply. This is just for conceptual purposes for people who are confused about this process of cross multiplication when you only see a number without a fraction. Okay? All right, let's continue. So basically, when we cross multiply, we're cross multiplying 1 minus the cosine of theta times the imaginary 1 in the denominator, and we're going to cross multiply this 1 plus cosine of theta with the 1 seen here. Okay? And we end up with 1 plus the cosine theta is equivalent to 1 minus the cosine squared theta. I think I said cosine previously, but I meant cosine squared. Sorry, because I'm rushing a little bit, so yeah, bear with me. Rely on what's written for the most part rather than what I say, unless I do an aside, which you should probably take really good heed to. Okay? All right, so now let's combine some terms and do some rearrangement to put this polynomial, what will be a polynomial, because you have different expressions with different powers. Here you have the second power, first power, zero power. All right. So basically, when we subtract 1 from the left-hand side to the right-hand side, we get 0. The ones cancel. Then when we subtract the cosine squared theta from the right-hand side and bring it over to the left-hand side, we get this cosine squared theta plus the cosine of theta is equivalent to 0. And now that this trigonometric polynomial is rewritten in standard form, we can easily factor and solve for theta, okay? And when I say standard form, I mean of the form ax squared plus bx plus c. That's what's, underlying the format here, okay? So let's start our factoring process. Basically, we factor out the cosine of theta. It's common to both terms, and we wind up with the cosine of theta times the cosine of theta plus 1 is equivalent to 0. Okay, so what we're going to do, as you can see, is set both terms, okay, equivalent to 0. Okay, so by setting each factor set equivalent to 0, we're exercising what's called the zero product property, okay? And the zero product property simply states that if A, this can be seen as term A, times B, this can be seen as term B, is equivalent to 0, then either A or B equals 0, or both, So a product of factors is 0, if and only if one or more of the factors are equivalent to 0. So let's continue with this process. When we factor the first term and set it equal to 0, we have the cosine of theta is equivalent to 0, or we have the cosine of theta plus 1 is equivalent to 0. Okay, so now let's go ahead and try to unveil theta. So in order to do this, we have to do the inverse cosine function. So when we take the inverse cosine of the cosine, we're just basically canceling out the cosine. We're undoing the cosine function to yield our theta trapped within it. And then when we take the inverse cosine of 0, we're going to find out the angle or angles which have a cosine equivalent to 0. I'll just give you a quick note that all the inverse functions in trig, they're basically going to get an answer that's an angle, okay? The result should always be the measurement of some sort of angle, usually an acute reference angle, okay? All right. So you should have memorized the angles in this interval, which have the cosine that's equivalent to 0. Okay, that's very important to memorize quadrantal. When I say quadrantal, I mean 90 degrees, 180 degrees, 270, and 360 degrees. You should memorize their trigonometric values and other common angles such as 30, 60, 45, okay, and 0 as well. All right, so before we take the inverse cosine of this function, we have one more step. We have to basically subtract 1 from the left-hand side, and we get that the cosine of theta is equivalent to -1. Now we can take the inverse cosine, and we'll undo the cosine function on the left-hand side, and we'll figure out which angle has a cosine value that's equivalent to -1, okay? So if we go back to the first factor, we get that theta equals 90 degrees or theta equals 270 degrees. If you perform this on your calculator, you're most likely going to get 90 degrees, okay? It's then your job to know which quadrant where the cosine is going to be not negative, it's positive. I know that's a funny concept, positive 0. And in order to yield theta, when you're in quadrant 3, you have to add 180 degrees. Okay, that's the general rule. But you can look at question 7 and I think 8 as well in this series to figure out how to do that, okay, because it shows you the quadrants and everything. All right, so now when we evaluate this expression here, we get that theta is equivalent to 180 degrees, okay? All right, but let's see, there's something funny here. We can't have theta being 180 degrees. You want to know why? Because when we go back and plug in 180 degrees into the equation, you're going to notice that you get a 0 in the denominator because the cosine of 180 is -1, so a -1 plus 1 is going to yield 0, and that's undefined. If you were to graph it, you'll have a vertical asymptote or something like that, okay? So we can't have that happening here. So yeah, that's not going to be one of our options. We're just going to X this bad boy out. We can't have you being one of our options, okay? So the only possibilities are 90 degrees and 270. So this is our answer. The solution set is going to be, let's see if I can, it takes me too long to write it out. I'll show you on the next page what I'm talking about. So the answers are 90 degrees and 270 degrees on the interval specified in the question stem, okay? We're not considering 360 because it's not included. The answer has to be less than 360, okay? And I just want you to understand that we could have avoided this extraneous root by simplifying the rational expression, okay? And when I say after we substituted for the sine squared of theta, we could have simplified this. That's what I mean. A rational expression is nothing more than a fraction in which the numerator and our denominator are polynomials. When I say polynomials, separate terms with different power. The one is a 0 power, this is a second power, this is a polynomial also. This is a first power term, this is a 0 power term, okay? So let's do just that, okay? We're going to basically notice that this is the difference of two perfect squares because the square root of 1 is going to be 1, and the square root of cosine squared is cosine. So we know that the factoring for the difference of perfect squares works out like this. 1 plus the cosine of theta times 1 minus the cosine of theta. Again, all divided by 1 plus the cosine of theta is equivalent to 1. Okay, so what we're going to do next is cancel the like terms and then simplify by rewriting. And when we rewrite our expression, we get that 1 minus the cosine of theta equals 1. And so if we subtract 1 from the left-hand side to the right, we get 0. And then to get rid of this negative, we just divide the entire equation by -1. And we still get that the cosine of theta is going to be equivalent to 0. And then we can carry out the same steps we did previously, take the inverse cosine function to figure out what theta is. And you're going to get 90 degrees on your calculator, but then you also have to remember to check the other quadrants, and the other angle within this interval that has a cosine of 0 is 270 degrees, okay? All right, I briefly mentioned calculator, and you know what? You could also solve this on your handy dandy graphing calculator. So if you're up for it, let's see how it's done. I promise it's way shorter than doing this out by semi-hand. When I say semi-hand, you still have to use your calculator to evaluate these types of portions of the problem, okay? So let's see how that's done. Alrighty then, so you can solve this, like I said before, using your graphing calculator, and it's accurate and easy, okay? So I'm going to be referring to the TI series, 84, 83, whatever, and even if your calculator is another brand, the methods are going to be pretty similar. It's just that the keys are probably called something different. So it's still good to watch and have your calculator out as you're doing so, okay? The first thing you want to do, since we're dealing with angle measurements in degrees, you want to ensure that you're in degree mode, okay? And you get here by pressing mode. It's going to bring up the screen. You're going to see the flickering cursor over the normal in the upper left-hand corner, all right? So what you're going to do is press the down arrow once, and your flickering cursor will be hovering over float. You press the down arrow once more, and your flickering cursor is going to be hanging over the radian indicator. Let's pretend that your calculator is set to radian mode. What you would have to do is then press the right arrow once, and you would get what looks like this. You're going to get the cursor hovering over degrees, okay? Now, you're locked in degree mode. You don't have to press enter. All you have to press is second mode to quit the screen and go back to your home screen, okay? So we're told in the problems then that this is our interval. So we also want to represent this within the brain of our calculator as well. So what you're going to do is you're going to hit window, okay? Then it's going to pull up the screen. The first thing you're going to do is let x minimum be equivalent to 0 degrees that is. Then you're going to press your down arrow. And then you're going to let x maximum be equivalent to 360 degrees by typing in 360. Then you're going to press enter once more, because you know what we're going to do now? We're going to set the x scale to 90-degree increments, because when we eventually view our graphs, it makes things neat and it makes the results easy to interpret, okay? So you do this again by pressing enter so that you're on the x scale line. Type in 90. Okay, and now that you specify the different values, you can leave the others alone. You're going to hit second quit to go back to your home screen. All right, let's keep it moving. The next thing you want to do is you want to put this expression into the brain of your calculator, but you can't just do it like this. What you're going to have to do is input two separate equations for the expression on the left-hand side and the term on the right-hand side of the equal sign, okay? And you do this by pressing y equals to pull up your y equals screen. So let's input this first expression, okay? So what you're going to do first is, you're going to isolate the top numerator by itself by opening up a set of parentheses. So you press open parentheses to get this. Now you press sign, and then you hit the x, which is hidden in your variable button, x, t, theta, n, okay? And then you close out the parentheses by pressing close parentheses, and then you close out the parentheses, well, and that's going to enclose your sign function, and now you're going to wrap the entire thing again in another set of parentheses, and then you're going to square that term, okay, by hitting the x squared button, and then you'll see this exponent pop up on your screen, and then you're going to divide to represent your fraction bar. Open up a set of parentheses again to isolate the denominator, and you're going to hit 1 because we have a 1. So hit 1 plus the cosine of x theta n, your variable button. You're going to see an x, but you can view it as theta. It's the same difference, so to speak. And then you close that out. You close out your cosine term, and you wrap the entire denominator again in a closed parentheses, okay? Now you also have to input 1. So you press enter. Okay. Hopefully you're still with me. Don't give up. If this is too long for you, play it on double speed or 1.5x in the settings button in the lower, I think it's the right-hand corner of your screen. You can find that, okay? So you press 1, second mode to quit. Now you come back to the home screen, but this is all inside of the brain of your calculator. Now, for general trigonometric functions, simple ones, the best viewing window is the ZoomFit viewing window, and you get there by hitting Zoom and the number 0, because 0 represents the fit option. And then what you get is something that looks like this, okay? So this is going to be the sine squared theta divided by 1 plus the cosine of theta. And this line here is where y is equivalent to 1. Okay, so our solutions will be at the points of intersection here and here. And already you can see that's 90, because remember our x scale is in 90-degree increments, as well as 270. But if you're unsure of the exact measurements, all you have to do is basically hit the calc feature by pressing second trace, and it pulls up a calculation screen which gives you different options for calculating different things in your graph. Okay, and so we're going to choose option 5 by hitting the number 5, because this is going to find out your points of intersection. And then what you have to